Prove the identity sine to the power 4x, so sine x and then raise it to the power 4, minus cos x to the power 4, or cos to the power 4x, equals 1 minus 2 cos squared x. So something like this is quite daunting, and it's quite hard to know how to start. But the key to this, well, look at what we're, well, remember, when we say prove, it means start from the left-hand side and end up on the right. It doesn't have to mean that, but for me personally, that's what it means. If I'm proving an identity, I'm going to work with the left-hand side, do as much as I can to turn it into the right-hand side. When I've gotten to the right-hand side, I know I'm finished. So we are aiming at an expression just with squares. So if you look at what the end target is, it's 1 minus 2 cos squared x. So we need to reduce the power. So can we write sine to the power 4x and cos squared x in another way? So bearing in mind they both are something given to the same power, if we can write them in such a way so we can get a sine squared and a cos squared in there, that is going to make this easier to work with. The key to this is recognizing that sine x to the power 4 is the same as sine x squared and then squared again. So I'll write that down. So sine x to the 4, that's just sine 4x, which is the same as sine x squared, which is sine squared x, and then you square it again, just basic powers on powers. So that's just sine squared x, and then you square it. Sine squared x squared, right? And obviously we can do exactly the same thing with the cos. So now we can begin. Sine 4x minus cos 4x equals sine squared x squared minus cos squared x squared. So now looking at this, we have a difference of 2 squared on our hand. So you have got something squared minus something else squared. Remember, a squared minus b squared is a minus b, a plus b. So this is going to be sine squared x minus cos squared x times sine squared x plus cos squared x, which we should know that simplifies very, very nicely. Just difference of 2 squares, sine squared x minus cos squared x sine squared x plus cos squared x. Right, so we've got it like that. We know that this is just 1. Remember, it's the Pythagorean identity, the most important, most common trigonometric identity. So this ends up just being equals sine squared x minus cos squared x. And then if we look at what we are aiming at, we want an expression just in cos. So what we should do is make a substitution for sine squared x, so there's only cos's in. And we know that sine squared x plus cos squared x is 1, so sine squared x can be written as 1 minus cos squared x. So equals 1 minus cos squared x minus the cos squared x that was already there. And we are aiming at 1 minus 2 cos squared x, so if we collect like terms, that's exactly what we're going to have. Equals 1 minus 2 cos squared x as required. So with these, until you actually get to double angle or compound angle rules, you're most of the time going to be using either sine squared x plus cos squared x equals 1, or tan x equals sine x over cos x. There are obviously the Pythagorean identities with sec squared and those as well, but most of the time you're going to be using one or both of them, the two most common trig identities.